This is the first lesson of the school year. And so what you should be doing at this point is taking your packet that was given to you and opening up the packet to this particular lesson. You always know every single day where we are within the packet by looking in either the left or the right-hand corner, making sure that you're at the right lesson number, and then also making sure that the title there matches up. It might not be perfect as far as the wording goes, but it should be relatively close. And then in the opposite corner, there will always be a listing of the specific standards that we happen to be using for the day. Now, you'll notice that even though this is an 8th grade lesson, these are all 7th grade standards because we're going to spend a few days kind of reviewing some of the important stuff from the previous year to make sure that we are good to go. And each day we talk about, we start on the very first screen, several things. First of all, the daily learning target, which is basically a quick summary of our focus for the day. And so as you can see today, students will be able to solve problems that involve adding, subtracting, multiplying, or dividing rational numbers. And rational numbers, if you have forgotten, are basically numbers that can be written as a fraction. So we're talking about decimals and fractions. And you are required each day to fill in the word that is there. Now, sometimes it's in red, sometimes it's not. So you'll just have to kind of figure that out. So right now you should be filling that in within your packets. The language targets really revolves around the idea that if we did do some shoulder partnering, that's kind of where our focus is for that day. So for today's lesson, students will be able to discuss solutions to problems learned in previous years. And in fact, the language target will probably be the same in these first few lessons. And then we always give an example of why you're learning this, and there's always going to be many, many reasons why. But for today, it's important for solving linear equations, which we do a lot of in the 8th grade. You did some of it in 7th grade, but we do a lot more of it in the 8th grade. So make sure you have those important words filled in the blank areas there. Okay. So, first of all, some integer review from, and that's actually should be 7th grade, not 6th grade. Used to be 7th grade. Oh, actually, this part is from 6th grade. So when you first started talking about integers in the 6th grade, you really talked about the number line, which for the first time involved positive and negative numbers. So something that might look like that. We typically call that the x-axis. And you might have put numbers in order from smallest to biggest and things like that. And when we're talking about a number line is typically one-dimensional. Now, as soon as we add a second axis that is vertical to that one, which is sometimes called the y-axis, we refer to that as a coordinate plane. And as soon as we do that, we're now talking about things in 2 dimensions, one by another. So we've got the x-axis and y-axis. So another thing that you would have done in the 6th grade is what we call plotting ordered pairs. And typically that's what your coordinate plane looked like in the 6th grade. So if we plotted a point right there, that specific ordered pair is 3, 2, because we started at the center or the origin, went 3 to the right, and then 2 up. Now, anytime we have an ordered pair, the first number always refers to the x number, or the amount or number of units you went in the x direction, so left or right. The second number always refers to the y number, or the number of units that you went in the y direction, so then up or down. So we went right 3 and 2 up to get to 3, 2. And once again, we refer to that as an ordered pair. Now, that ordered pair that I just plotted right there, that is a very important ordered pair. That is the ordered pair 0, 0, and there is a name for that. The name for that is the origin. And the reason why it's sometimes referred to as the origin is that's where we always start before we move left, right, up, down, and then plot a specific ordered pair. So that's just a quick review of ordered pairs from the 6th grade. So I would like you to quickly go ahead and plot all 4 of those ordered pairs. I'll do the first one with you. So A refers to the ordered pair -3, 1. So if you start at the origin, go to -3, so that means you have to go to the left. Remember, the first number refers to left or right movement. The second number refers to up or down movement. So from the origin, we're going to go 3 to the left and then 1 up, and there is the ordered pair A. Go ahead and plot B, C, and D, and if you're watching this at home, just pause the video very quickly. All right, so anytime you're doing specific problems, you should pause the video and then play the video again to make sure that you did things correctly. So ordered pair B is 5, -4. So starting at the origin, we go 5 to the right and -4. So that's where ordered pair for B is at. C is -4, -6. So we go 4 to the left and then 6 in the downward direction. And D is 0, 5. So we start at the origin and the first number is 0. So that means we do not move left or right. We stay right at 0. But then we go up 5. And sometimes we have ordered pairs where we don't move left or right, or maybe we don't move up or down. And anytime we have one of those two things, that means the ordered pair will either lie on the x-axis or on the y-axis. And then this one happens to be on the y-axis. So let's kind of go in the reverse order now. Here in this picture for number 2, you can see that I have 5 ordered pairs plotted, and you're supposed to list them as ordered pairs. So for example, 3, -2 is referring to that ordered pair right there because we went 3 to the right and then 2 in the downward direction. So that's 3, -2. So why don't you go ahead and pause this video and go ahead and write down the other 4 ordered pairs. All right, so another ordered pair would be at 4, 1, which happens to be that ordered pair right there. Another one would be -3, -4, which happens to, of course, be that ordered pair right there. And then we have 0, 2, which happens to be this ordered pair, and that happens to be on the y-axis. And then the other one that we have not done yet, -4, 0, happens to be this one because we went 4 to the left and we did not go in the up or down direction because the second number was 0. So that would be if you have points and you're asked them to actually write them as ordered pairs. All right, next. So in 7th grade, you did do some plotting of some ordered pairs, but we also took that up to actually adding, subtracting, multiplying, and dividing positive and negative numbers. And the way that we typically did these, and I'll kind of help you through the first 3, and then I'll have you try the last 5, is the way that we did them is we did it by comparison when we're adding or subtracting. So if we take a look at the first problem. So -12 plus 9, we have 12 negative numbers. And I'm writing that number down first, not because it's listed first, but because we have more negative numbers than we do positive numbers. And then we have 9 positive numbers. So if we compare those, clearly we have more negatives than we do positives, which makes the answer negative. And we have 3 more negatives than positives. So that means that negative 12 plus 9 is negative 3. Now, what we did last year was we tried to turn all subtraction problems into addition problems. And then the way that we did that was by something we called adding the additive inverse, or sometimes it's referred to as adding the opposite. So you keep the first number what it is, you change the subtraction to addition, and you change the second number to the opposite of what it is. So that's adding the opposite. So at this point, if we look at what we have left, we have 8 positives and 6 positives. So technically we have 14 positives and 0 negatives. So clearly we have more positives than we do negatives. In fact, we have 14 more positives than negatives. And what happened last year was some of you got to the point very quickly that you didn't really need to add the opposite. You could just sort of intuitively figure out what the answer was in your head. And that's fine, but I'm going back to the way that we did everything last year in case you have forgotten how we approach these sorts of problems. And so if we look at the third problem, much like the previous one, it is a subtraction problem. So once again, what we did was we like to think of all subtraction problems as addition problems. And we did that by adding the opposite. So once again, you keep the first number the way that it is. You change the subtraction problem to addition, and then you change the second number to the opposite of what it is. Well, right now it is a positive 6. So we changed it to a negative 6. So that's adding the opposite. So negative 8 minus 6 is equivalent to negative 8 plus negative 6. So now we're going to deal with this the same way that we dealt with the first 2 problems. We have actually 8 negatives and 6 negatives, so that means we have 14 negatives altogether. And we have 0 positives. Clearly we have more negatives than we have positives. And in fact, we have 14 more negatives than we have positives. So therefore, the original problem was negative 8 minus 6. Negative 8 minus 6 is negative 14. So I would like you to go ahead and try the last 5 problems. Please notice that the next to last one is multiplication. The last one is division. The rules for multiplying and dividing are clearly different than adding and subtracting. Go ahead and try those 5. All right, the next problem is negative 13 minus negative 5. What we really should be doing is we should be thinking of this as an addition problem, so adding the opposite. We have 13 negatives and only 5 positives. We have more negatives than we do positives. In fact, we have 8 more negatives than positives. The next one, negative 12 minus negative 6. Add the opposite, so that is equivalent to negative 12 plus 6. Much like the previous problem, we have more negatives than positives, which makes the answer to this negative. And we have 12 negatives and only 6 positives. Since we have 6 more negatives than positives, the answer there is negative 6. The next problem is already an addition problem, so we can leave it like it is and think about it by comparison. We have 18 negatives here, because we have 6 negatives and 12 negatives, 0 positives. So clearly we have more negatives than positives. In fact, we have 18 more negatives than positives. And now we have a multiplication problem in the next one. So remember, the rules for multiplying and dividing kind of work like this. If the signs are the same when you are multiplying or dividing, the answer will be positive. If the signs of the numbers are different, the answer will be negative. Well, we have a negative number that we're multiplying by a positive number in the next problem. That means the signs are different, so therefore the answer will be negative. And then from there, 7 times 10 is 70. So the answer there is negative 70. And in the last problem, the signs of the numbers are the same. So remember, anytime we multiply or divide numbers, the signs are the same like they are in this one, the answer will be positive. So from there, 54 divided by 9 is 6. So the answer here is positive 6. So that was just a quick refresher on integers. So let's now go to next problem. And so what we did from there is we went to decimal values and fractions, and we reiterated from an earlier grade that anytime you're adding or subtracting, you have to have the same units. So if you're adding apples together, you can add 3 apples and 4 apples because we have the same units there. If we have 24 and 7, we had to put the 7 below the 4 because we had to line up the same units, or in this case, the 1. Same units. Same thing when you're adding decimals. You have to line up the ones and the tenths and the hundredths so that you're adding same units. And then the same thing is true when you're adding or subtracting fractions. When you have 1/2 plus 1/3, you can't just add them together the way that we have there. And the reason is because we don't have the same units yet. That's the reason why we convert to the common denominator, so that we now have sixths and more sixths that we are adding together, because now we have the same units, and that's what makes that 5/6. If we don't have the same units, we can't combine or add things together. If we have 3 apples and 2 bananas, that's not 5 apple bananas, because there's no such thing as an apple banana. We don't have the same units there. If we have 24 and 7 that we're adding together, we can't add it together like that. You can't put the 7 underneath the 2 because you have a tenth that you're trying to add to a 1, and we don't really do things like that. And that is a common mistake for people who struggle with math. And the same thing when you're adding decimals. You don't do things like that. So we can only add things if we have the same units. And same thing with fractions. You can't just say that that's 2/5, because it's not. We have to do some converting before we do that. So don't make those careless mistakes. So then we went to adding and subtracting negative and positive decimals. But it works exactly the same way as it does with integers. So if we take a look at number 4, we already have an addition problem, so we can leave it the way that it is. And in this particular problem, we have 12.7 negatives and 17.7 more negatives. So all we have are negatives. So we have 30.4 negatives, and we don't have any positives. Clearly, we have more negatives than we do positives. In fact, we have 30.4 more negatives than positives. All right, go ahead and pause the video and try number 5 and number 6. And then when you're finished, unpause it or play it, and then see if you got the right answer. All right, for number 5, we clearly have more positives than we do negatives, because we have 15.7 positives and 9.22 negatives. So we should put a 0 right there. So once again, we have more positives than we do negatives. So I don't need to write the plus symbol in a positive answer, but I'm going to go ahead and write it down that way. So now the question is, how many more positives do we have than negatives? Well, let's figure that out. Going to have to do some borrowing. And it looks like we have 6.48 more positives than negatives. In number 6, we have more negatives than we do positives, because we have 3.11 negatives and 3.3 positives. Probably should put a couple of zeros there so that we have same units. And now we're trying to figure out how many more negatives we have than positives. And anytime you're trying to figure out how many more you have of one thing than another, that's typically subtraction, how we figure that out. And so it looks like we have 0.211 more negatives than positives. If you need to pause this to write stuff down, go ahead and do that, but I'm going to go ahead and go on from there. Okay. Subtraction, same idea. The only difference here is that we would need to add the opposite on all of these subtraction problems. So I will do the first problem with you. Remember, we are adding the opposite. So 4.9 minus 14.6 is equivalent to 14.9 plus negative 4.6. So now the problem is no different than the previous screen. We compare our positives and negatives. Clearly, we have more negatives than we do positives because we have 14.6 negatives and only 4.9 positives. So we're trying to figure out how many more negatives than positives. We're going to have to do a little bit of borrowing here. But it looks like we have 9.7 more negatives than positives. So therefore, 4.9 minus 14.6 is negative 9.7. Go ahead and try number 7, 8, 9, 9, and 10. Go ahead and pause the screen, do them, and then compare, and then play the video so you can see if your answers are right or wrong. All right, taking a look at number 8. We should change this to an addition problem, so we add the opposite. And I'm going to go ahead and erase this so I have some room here. And in this problem, we have more positives than negatives, and the reason is because we have 22.6 positives and 7.81 negatives. You can clearly see we have more positives than negatives. Probably should put a 0 right there so we have common units. And so we're going to have to do some borrowing here. And it looks like we have 14.79 more positives than negatives. Number 9, add the opposite. It looks like we have 24.52 positives now and only 2.9 negatives. Probably should put a 0 right there. And so once again, we have more positives than negatives. So now we need to figure out how many more of that. So do some more borrowing once again. And it looks like we have 21.62 more positives than negatives. And then in the last problem, add the opposite. All we have are negatives here. Let me erase to free up a little bit of room here. And it looks like we have 18 negatives and 16.8 more negatives. That is 34.8 negatives and 0 positives. Clearly, we have more negatives than positives. And in fact, we have 34.8 more negatives than positives. So that is a review of a lot of things there. Plotting ordered pairs, writing down ordered pairs from 6th grade, integer and decimal review of adding and subtracting integers and decimals. And multiplying and dividing is all easy because the only thing you need to really determine is the sign. So probably a good idea for you to pause this video, go ahead and start on the assignment, and then tomorrow or the next day, if this is Friday, go ahead and resume the video and start at the next idea, which is adding and subtracting, multiplying and dividing, positive and negative fractions. But I'm going to continue on here. All right, so fractions, anytime we add or subtract fractions, we need to make sure that we have the common denominator so that we have the same units. And in number 11, we have two denominators, 8 and 6. You typically want to try and find the least common denominator, because if you always go with the strategy of just multiplying the two denominators together and using that, a lot of times you end up having to reduce. Particular problem, when we have 8 as a denominator and 6, the least common denominator happens to be 24. And so we're going to change each of these fractions into equivalent fractions that have 24 as the denominator. So that would mean that we would need to multiply 1/8 by 3 over 3, which makes that 3/24. And that's, when we're doing something like that, that's called the identity property of multiplication. Because what the identity property of multiplication states is that you can multiply any value by 1 and you don't technically change its value. In the second fraction, we're going to have to multiply by 4 over 4. And the reason is because 6 times 4 is 24. And since we multiplied 6 by 4, we have to multiply the numerator by the same number. And 5 times 4 is 20. And so 5/6 is equivalent to 20/24. So now we technically have a 3/24 minus 20/24. So from there, you really now have 3 minus 20 over 24. Now, it should be obvious to us that our answer will have a denominator of 24. As far as the numerator goes, this is what we were doing in the previous part of the lesson. So we really should add the opposite. We have 20 negatives and only 3 positives. We have 17 more negatives than positives. So what that means is 1/8 minus 5/6 is negative 17/24. And that's what number 11 should be. And I'm just kind of going through the steps one more time here to make that. All right, number 12. Anytime we have mixed numbers within a fractional problem, we really should turn all mixed numbers into improper fractions. So negative 1 and 7/8 is equivalent to negative 15/8. And I can see that the common denominator is 8. And since the first mixed number already had that as the denominator, we're good there. We just need to change the 3/4 into 6/8. And then we have negative 15/8 plus 6/8, which is negative 15 plus 6 over 8. As far as the numerator goes, we have 9 more negatives than positives. And so that is negative 9/8. But many times we're asked to turn all improper fractions into mixed numbers. We know that the answer is going to be negative, and from there it'll be negative 1 and 1/8, because 8 goes into 9 once with the remainder of 1. And that's really a combination of 5th, 6th, and 7th grade stuff there. All right, going on. Please pause the video, and I'll have all of you try number 13. And then once you think you have the correct answer, play the video and see if your answer is right or wrong. All right, so first of all, we're going to turn both of these mixed numbers into improper fractions, and then we also should turn this into an addition problem, an equivalent addition problem, so make sure we add the opposite there. And so 6 and 1/4 is equivalent to 25/4. 1 and 3/5 is equivalent to 8/5. Now we find our common denominator. The least common denominator is 20. So 25/4 is equivalent to 125/20. 8/5 is equivalent to 32/20. Now we have 125/20 plus 32/20, which becomes 125 plus 32 all over 20. That happens to be 157 over 20. We can see that the answer will definitely be positive, because we have a positive divided by a positive. And now you're trying to figure out how many times 20 can go into 157. If you can't do that in your head, you might want to do a little bit of work off to the side there. 20 goes into 157 7 times. And 7 times 20 is 140. And we have a remainder of 17. So that means 157 over 20 is equal to or equivalent to 7 and 17/20. Okay. Try number 14. Go ahead and pause the video, do the problem, then play to see whether you got it right or wrong. All right, at number 14, we already have an addition problem here. That means we don't really need to add the opposite. Least common denominator is 12, so we're going to turn both those fractions into twelfths. Negative 3/4 is equivalent to negative 9/12. Negative 2/3 is equivalent to negative 8/12. So technically we now have negative 8/12 plus negative 9/12 plus negative 8/12, which is equivalent to negative 9 plus negative 8 over 12. That happens to be negative 17 over 12. And then 12, well, first of all, we know the answer is going to be negative because we have a negative divided by a positive. 12 goes into 17 one time with a remainder of 5, so that would give us negative 1 and 5/12. And if we were in class today, of course, we have sentence frames just the same way that we had them last year. That's why those have been at the bottom of every single screen. All right, let's go to number 15. Pause the video, try number 15, and then play to see whether you got it right or wrong. Much like several of the previous problems, we need to turn into improper fractions first. Therefore, we have negative 8/3 plus negative 16/5. Least common denominator is 15, so let's turn them both into 15ths. Negative 8/3 is equivalent to negative 40/15. Negative 16/5 is equivalent to negative 48/15. We now have negative 40/15 plus negative 48/15, which is equivalent to negative 40 plus negative 48 over 15. All we have are negatives, so we combine them together. We have 88 negatives and 0 positives, so therefore we have negative 88 over 15. We have a negative divided by a positive. We know that the answer has to be negative. And 15 goes into 88. If you can't do that in your head, do some long division off to the side. And what I mean by that is, like I did 2 problems ago, 88 divided by 15. When you figure that out, it looks like that's 5 times. So we have negative 5. 5 times 15 is 75. We have a remainder of 13. So that means we end up with negative 5 and 13/15. All right, one more fraction problem, and then we'll go on to the last thing for this 2-day lesson. Everybody try number 16. Pause the video. When you think you have it, play the video to see whether you're right or wrong. All right. Much like several of the previous problems, convert to equivalent improper fractions. 1 3/4 is 7/4. We probably should add the opposite right here. I know I do that at some point, but you need to make sure that you remember to do that. 2 1/7 is equivalent to 15/7. Common denominator is 28, least common denominator. So 7/4 is equivalent to 49/28. 15/7 is equivalent to 60/28. So we now have 49/28 minus 60/28. And I think right now is where I'm going to add the opposite. And you could have done it earlier or waited. It doesn't really matter. So now we have 49 minus 60 over 28, which becomes 49 plus negative 60 over 28. We have more negatives than we do positives in the numerator. In fact, we have 11 more. So therefore, we have a difference of negative 11/28. Okay, last idea for this lesson. Going back to around 5th grade, you learned how to first evaluate algebraic expressions. You also did this in the 6th grade. And that's simply where you replace a variable with a number and then use the order of operations to simplify. So some key terms in this definition are algebraic expression, and that's from 6th grade. A variable, which is from 6th grade. Order of operations, which also that term is from 6th grade. Simplifying, you've been doing that for a very long time. So an example of this is if we have the expression 2x minus 4, and we're asked to evaluate that when x is equal to 3. All that simply means is we're going to replace the variable x with the value of 3, like I just did, and now I'm going to use the order of operations to simplify. Well, we always have to multiply before we subtract, so we will multiply 2 times 3. That happens to be 6, and then 6 minus 4 is 2. So you've been doing this kind of thing at least since the 6th grade, perhaps even in the 5th grade. So you've been doing this kind of thing for a long time. So what I would like you to do is I'm going to do number 17 with you. We're going to evaluate the expression AB minus C if A is 3, B is 4, C is negative 5. So we're going to replace those variables with each of those values, like I just did. And then we're going to figure out what that simplifies to. So we have to multiply 3 times 4, which is 12. So now we have 12 minus negative 5, and you can see why earlier in this lesson we reviewed all of that. 12 minus negative 5 becomes 12 plus 5, and that happens to be 17. All right. Everybody try number 18, pause the video, and then play it to see whether you got it right or wrong. All right, so we have 2a times the quantity. That's how we state that when we have things inside of the parentheses. 2a times the quantity, c minus b. So we're going to replace a, b, and c with their values. This is what I have. Now follow the order of operations. We would need to do the 2 times 3 first, which is 6. Actually, no, we need to do within the parentheses first. So negative 5 minus 4 is negative 9. And now what people typically will do is multiply from left to right, since we have 2 times 3 times negative 9. The commutative property says we could multiply in any order. It doesn't really matter. But regardless of that, we get negative 54. All right. Everybody try number 19. Pause the video, then play it when you think you have the correct answer. All right, so we have 2a plus b divided by 2. So we'll replace a with 3 and b with 4, and then follow the order of operations. So we should do the 2 times 3 first. Now here's the tricky part. 6 plus 4 divided by 2. Order of operations tell us from 6th grade and 7th grade. We do within parentheses first, then we deal with exponents if we have any, then we multiply or divide next, whichever comes first, then we add or subtract last. So we need to make sure we do the 4 divided by 2 right now, and so we have 6 plus 2, and that happens to be 8. All right, everybody try number 20, pause the video, and then play when you think you have it correct. All right. We're replacing a, b, and c with their values, which gives us this. Now follow the order of operations. We have to add the 4 plus the negative 5, which is negative 1. And anytime you have order of operation problems where we have fractions, we need to simplify the numerator first, then simplify the denominator, and then see if we can do any simplifying from there. Not much we can do here. We can simplify the numerator, and we can't really do anything beyond that. So I'll use the sentence frame in this one. So the solution to number 20 is negative 2/3. So the reason why we reviewed that is because we do a lot of evaluating expressions in the 8th grade, but in terms of formulas for geometry. So we're going to start in the upper left-hand corner there. We're asked to evaluate 7x minus 5 if x equals negative 9. So all that means is we're going to replace x with negative 9 and then simplify. And in these particular problems, I will provide a calculator for you in the homework because we have a lot of geometry stuff going on here. So if you have access to a calculator right now, go ahead and use one. And so from there we have 7 times negative 9 is negative 63. And negative 63 minus 5 is negative 68. Let's go to the one right next to that on the right-hand side. We do some geometry things with this symbol right here in the 8th grade, which I think a lot of you already know that is the pi symbol from 7th grade. We did some area and circumference of circles where we had to utilize pi, and we use the value 3.14 for pi. So we're going to evaluate the expression pi r squared h, which means pi times r to the second power times h. So what we have here then is that we have 3.14 times r to the second power, so 2 to the second power, and then times h, which happens to be 8. So go ahead and use a calculator to figure out what that is. Now remember, you probably should do 2 to the second power, which happens to be 4. That's from 6th grade before you go any further. All right, so that should be 50.24. So what I would like you to do is, if you didn't use a calculator for those first two, make sure you get one now. And what you could do is you could actually go ahead and open up the homework to the very last problem, which has a calculator embedded into it, and go ahead and do those last 3 problems. Okay, so I'm gonna do this problem next, but I need a little more room, so I'm going to do it down here. So we have 1/3 times pi, which is 3.14, times r to the second power, which is 8 to the second power, which happens to be 64, and then times 9. That's this problem right here. When we do this problem right here, we're going to have m, which is 4, times x, which is 5, plus b, which happens to be 6. So once again, that's this problem right here. And then as far as the last one, I actually have room right here to each of them. Okay, so the first thing you need to do is, 9 to the third is 729. Let's see here. Right here, 8 to the second is 64. And then go from there. The great thing about using that calculator that's embedded into that very last problem is it does have a fraction button embedded in there. So it does make these kind of problems a little bit easier to deal with. So I have to take off the writing. So for this one, you should have ended up with 602.88. For this one, you should have ended up with 26, and that one should have been easy. And then the very last one is 3,051 times 88. And finally, we should be finished with this 2-day lesson, and we will end when we have class all of our lessons where I ask a question, what did you learn today? So that would be where you need to kind of think back to what we talked about. And you should have thought about things like ordered pairs and adding and subtracting decimals and fractions and evaluating expressions. So that is it for today.